Okay, good morning, everyone. Welcome to, I guess this isn't a welcome, but I'm great to be here for day 3. And I'm pleased to introduce Michael Rocky from Brazil. He's in the Department of Entrepreneurship and Management, and he's here to speak to you about Polymathy. So take it away, Michael.
Thank you very much, Dan. Well, I've been doing research on the theme of polymathy, unstructured, since 2011, and more structuredly since 2013. And when you delve yourself into a topic so much, sometimes you forget a little bit of how you can introduce that to someone else who hasn't had such immersion on that thing that you are having for such a long time. And the first question here is, why polymathy? Why would that matter, right? And I will start with a short story, and then I will try to extrapolate how it can be helpful, not only for me, of course it was for me, but for other individuals and for society in general. And my analogy goes this way. Imagine like the primordial soup when you have those very complex compounds, right? And they have been for a while there. They are already complex, but they are scattered, right? And then if a lightning strikes come and something happens, like two compounds come together, and that was like polymathy to me. I had so many small things in my life that hinted me about the importance of integrating different skill sets, worldviews, different, how could I say that? There is another term, but different realities. And then when I got access to this term, it all came up. And then I had this new molecule, very voracious, that started collecting other molecules and making a new compound itself, which kind of integrated my personality and took it to a different, let's say, level, all right? Oh, that's my story. That's why polymathy is important to me. But why would it be important to someone else? I think there are, indeed, a lot of people who have felt more or less the same thing. It has been around. Simonton is famous for some research on doubles and triplets. I mean, not the kids that have doubles and triplets, but when a discovery is made twice or 3 times independently. And there is a very interesting concept from biology, which is convergent evolution. It means when you have a very good solution to a problem, and problems repeat themselves. For example, birds evolved feathers, probably for reasons of temperature regulation, and then they discovered it was good to do something else, fly. And wings evolved for birds. But wings did not only evolve for birds. They evolved for bats in a different circumstance, in a totally different way, for butterflies, insects, and other animals. But the solution, the elegant solution of wings, were invented independently in different circumstances. So it's a hint, this is a good solution to a more or less universal problem. So I think that many people may have felt this similar thing as I have. Well, we live in a very complex world and we have several constraints. I'm an economist too, so we always work with constraints, with scarcity. And well, what can I do with my time, my brief time here? Well, the decision of most people, or maybe they would like to explore more, but they have a lot of moderators, a lot of pressure from society to choose and specialize. That's a word that I don't like to use, because it's very misleading. I'm not against expertise. I will show you that expertise is a core element of polymathy. But I'm against the idea or the closed idea that you have to be X, and that X excludes several Y's and Z's and whatever else, all right? That means that, okay, you can only be expert in something, this X. All right, let's go on. I'm a researcher. I promise this is the only quantitative graphic that I will show you today, all right? Not gonna bore you with that. But it's a very interesting study by, let me use the, by Karwoski, very recent study. They measured, Karwoski and colleagues, sorry, they measured the correlation of a measure of fluid intelligence with creative achievement, right? So they had a specific test for how many things have you achieved. It's not, are you creative in general? No, have you had some achievement, some creative achievement? And they found this. If you are naive, you may believe in this line, right? It's a regression line. And one thing that I like to tell students when they look at a scatter plot, these are not dots, okay? These are people, okay? Each dot here is a person, and there is a reason behind why is that a person here and not here? And why is this guy here? I want to call Karwoski because I want to interview this guy here. But his main hypothesis is that there is a threshold that when you are to this side of the graph, let's say, it's very difficult to be very creative. And when you get more intelligent, you are you open the possibility of creativity. All right, but we shouldn't immediately, let's say, buy on that, on the whole of that. That's very important, very great research. But let's analyze this way. Okay, forget this part. Let's analyze this. What kind of relationship do you see? You can answer me, no problem, it's open. What, do you see any relationship here? No. No. All right. So after, that's average intelligence, all right? Doesn't matter. Doesn't matter. The most creative guy here is average. And you have the most intelligent guy, he has very little creative accomplishment. Well, what would you expect if the correlation was indeed true throughout? You would expect that those guys would not exist. They would be here, all right? And these guys would not exist. They would be here. There is some anomaly, we call. Economists also love the word anomaly. So you expect something, and reality shows something else. So we have this intelligence puzzle or anomaly. So there is something else. You can't explain creativity with intelligence. What is this something else? Okay, not gonna answer. And I think you've all been to Sternberg's talk, and based on his and a lot of people's findings, not only findings, but theories, I made it up, okay? This is not true data. That's just an illustration. What this illustration says, the more domain knowledge you have, good for you. You're gonna be more creative. That makes sense. If you have zero domain knowledge on a specific problem, for example, I cannot solve a physics problem because I have very little knowledge on physics. But as my knowledge goes up, my probability maybe of being creative increases, okay? So I can think of different things. Maybe I think, oh, we have this problem, we have this Maxwell equation that doesn't fit with Newtonian physics, and oh, but I have to be acquainted with these problems. I have to understand Maxwell's equation, which is, by the way, a marvelous equation, and I have to understand Newtonian physics. And with that knowledge, I maybe can think about, oh, that's a different problem. Maybe light, one says that light is fixed, the other says that light has a variable speed. That cannot be, right? Maybe the problem is time and simultaneity. And if I think of time and simultaneity, I think of two lightning strokes happening at the same time, and a person in a train wagon seeing one lightning, and then another lightning, and a person standing there on the station see the same lightning, see the two lightning strikes happening at the same time. And what is this theory? That's relativity, all right? And Einstein, he went very well with the special theory of relativity, the specific theory, the first one. But for the general one, he needed the help of other mathematicians. He was not as good, he was much better than the average person or even the college graduate. Don't get me wrong, he was good, but he was not the super expert in mathematics, okay? So many authors have argued on that. There is an optimum stage here and something happens. Some shock, let's say, makes people in this part of the graph behave less creatively. And maybe the answer is entrenchment. They get entrenched in their careers, which prevent them to see new worldviews, to think the problem of Maxwell equation as a problem of time. Who would say that in 1900s? Nobody, just Einstein. That's why he's Einstein. Okay? These were two puzzles from the literature, and now I'm gonna talk about some pro-polymathy evidence. Polymathy is there, and Ruth Bernstein, Robert, and Michel have been very important seminal authors and researchers on providing us with this insightful evidence that's only one graph, okay? I just chose one randomly. You can just look at their work. There will be several evidence for that, but I just choose one I look neat. But more eminent creators tend to be more polymathic. They tend to integrate different worldviews into their main vocation, into their main problems, okay? And we have the very interesting, and that's something that I would like to invite the community, the scientific community, to explore more, which is the novice effect. Which means when you enter a new discipline, when you change little, not necessarily you go from one domain to the other, from, okay, I am an artist and then I am a scientist. Not necessarily so abrupt, but when you integrate little different stuff into your research, when you are a researcher, okay, that's your main purpose. But if you send an article to a journal in one topic and then to a slightly different journal with a different approach, because you are, just changing a little bit your focus, generally it leads to a new burst of creative activity, all right? People who don't do that, and the perfect example to me in the work of Ruth Bernstein and others in 1993 is the comparison of James Watson, the guy who discovered together and based on the work of others the double helix structure, and Fleming. If you look at the work, if you look at the output of Watson, it's all in the same subfield. One thing, all the same, all the papers, pretty much in the same field. If you look at Fleming's life, he has been creative throughout his life, and his production changes, okay, over time. All right, so let's go to let me try to be a little bit more rigorous now. Well, we do have a much better definition now by Michel and Ruth Bernstein of polymathy, but let me start with the traditional definition, which is expertise in multiple domains. And you all been kids doing tests, and when you have a difficult test, what do? You go to the most easier question first and try to solve it, okay? So you have 3 elements here, and the easy one is multiple, all right? Everybody knows that polymathy entails multiplicity. It's in the name, the Greek name. Poly means various, okay? That's all set? Everybody agrees? Okay, but nobody agrees what expertise is. Nobody agrees what the domain is. And I think nobody should agree here. Okay, so let's go. Expertise, I called an expert in expertise to define it. Take a moment to read it, Hurling 2000. But for me, nothing is new under the sun, right? So one thing that I really like to point is that for this guy, expert in expertise, expertise entails or is the combination of experience, knowledge, and problem solving. Oh, interesting, but how new is that? Think of the ancient Greeks. They have the word empiria. That's the root for empirical knowledge. Knowledge that you can grab by your hands, which Heraclitus said that's the real knowledge, not the traditional knowledge from poets and books. But imagine on the time of Heraclitus, people gathering knowledge from stories and believing in that. Sounds like what? Fake news. So Heraclitus hated that and said, oh, that's not true knowledge. That's malpractice. You're gathering knowledge from sources you cannot trust. You must be there. You must feel. But come on, the world has evolved. We have a scientific community. So we have epistemic knowledge that's more or less trustable, right? So you have many theories. I believe in E equals mc squared. Have I tested? Of course not. Even Einstein took like 15 years to be able to really test empirically his theory. In fact, the war came into the way. That's a very interesting story. But we have experience, we have conceptual or epistemic knowledge, which is principled knowledge. You know why things work. You know the principles behind. But you also have problem-solving skills. To solve problems in different domains, many people would think you're gonna need different tool sets, right? The problem is, if you only have a hammer, every problem will look like a nail. That's a classic problem. And polymathy is when you have a more diverse tool set and you're able to handle the tools correctly. But that's not new too. Maybe, that's my view, the Greeks would call it techne, which is the root of technique, which sometimes you can have the technique, but not the underlying principle, right? You have no know-how, but do you explain how can you do that? Sometimes you don't, okay? So that's expertise. And let's go to the third element, which is the domain. The domain, based on the works of Csikszentmihalyi and Simonton, is the collection of facts, concepts, techniques, goals, heuristics, Okay, so every domain is a piece of culture that has been bounded together, all right? But that's an artificial construction. Who can say when the domain of biology ends and chemistry starts? Or when chemistry ends and physics starts? It's difficult. It's arbitrary, all right? So one good thing to do is to sometimes, not always, sometimes get rid of those boundaries and just stick with the facts, concepts, techniques, heuristics, goals, whatever, that work. All right? And then I have, I'm gonna talk about 3 types of integration, which I pose as a third vital component of polymathy. But let's start with this molecule here, all right? This is a complex thing, a complex construction. It's bound this way, all right? The connections are there, but good thinkers, they go back and forth. They don't believe in that. they understand the utility of that, but they don't believe in that. They break it into parts. Okay, but maybe this part is not the best part to fit in here, or maybe I can graft something different here. So they go they analyze, they break apart, but they also integrate. They see how these different things can meld together to form different stuff here. So this is what I call back and forth ideation. And then you have another kind of integration, which I really want you to participate. That's aluminum, okay? Well, you all know aluminum. What are the characteristics of aluminum? It's
light.
Light, but it's not only light.
Conducts heat.
Yes.
Dependable.
Dependable, perfect. What else? Is it weak? Moderately strong, depending on the alloy, right? Okay, so imagine, let's go back to the 50s, okay? You are in the aviation industry, you build aircraft. Aircrafts are made of wood. Wood rottens, wood is not good, people die. I'm laughing, but this is a tragedy, in fact. And they start using aluminum, all right? And then you are an aircraft engineer in the 50s. You see that, okay? You work in this industry, you get paid, you're happy, but then you take vacations north up here when it's cold, and what can you do here up north when it's cold in the mountains? You can ski, all right? Back in the 50s, skis, I haven't ever had the opportunity to ski, but people say it's very difficult, right? And this guy, or you are a guy, and you're trying to ski, it's hard. And then you think, oh, I'm an engineer, and I've solved a problem here, right? Of aluminum. And why not make aluminum skis? This is Howard Head, the inventor of I'm not saying inventor, but he put a different material and made the skis lighter. And he not only helped himself because he couldn't ski right, he helped to create a new market. He made skiing easier to millions of people, all right? Okay, so there is another empty space here. Think of another thing that we could apply the same concept. Okay, forget winter, go to the summer.
Boats.
Boats, one thing.
Soda cans.
Soda cans.
Water skis.
Huh?
Water skis.
Water skis. Think of another sport that used wood.
Baseball bats.
Tennis. That's it.
Okay.
The guy used the same concept in tennis. He invented the big head, his name, racket, okay? Which also made tennis easier. Okay, tennis I know, I have played. Which is much easier to hit with a big racket than with the wooden one with a very small sweet spot, right? So it's functional integration, something that works in aviation, works in skiing, and works in tennis, all right? All right, let's go to another kind of integration that I really love, homeostatic. Why do I use this strange word? It comes from medicine. For example, you have the sleep-awake homeostasis, which means the longer that you stay awakened, the more drowsy you begin to feel during the day, and the more you sleep, the more energy or you can recover, all right, during the night. So there is a balance, and I applied it to our psychic energy, all right? And that's based on the work of Ruth Bernstein and others also. The best creative persons in the world, they don't think, okay, I have to work because doing something else is a waste of my time. You are being foolish because your resources are scarce. You know, your attention, it drops very fast. Law of diminishing returns, right? And then what those genius people do, they balance their lives. That's Vladimir Nabokov, writer of Lolita. And he was not an avocational entomologist, a guy who studies insects. He was a true scientist. he made contributions in that field. And during the trips to collect butterflies, analyze them, maybe draw them, he wrote Lolita. And some observers say that there is a superordinate capacity that informed both his writing and his analytical skills, because he was an awesome describer. He could describe the sensations of being that older guy, bewildered with this young lady, and he was very good at it. It may have helped both domains. And that's our famous Einstein. And if you read the work of Robert, you're gonna see in various moments in biographies, of course, of Einstein, how important it was to be a musician, to inform that kind of thinking that no other physicist had. Only him could think about Maxwell equations in a different way. Okay, so we have the last one, the last type of integration, which is the best one, which I call personality integration. And, okay, I don't have the text here, but we have had different words for that. For example, Gruber talks about integrative networks of enterprise. Okay, so you have an enterprise, maybe a main enterprise, but you have other networks that work together to help you integrate all those activities into your life. It also is related to very core concepts of psychology, like self-actualization. I could cite Maslow. He died before he finished the pyramid, by the way. The next step would be, after you self-actualize, you must leave something else, something new to society, which is creativity. And Gordon Allport, propriative striving. There is I think he was a bit naive that we can, after we finish our adolescence, we are going to be a complete whole. Okay, that was very optimistic, but that's a very good concept when you can integrate different things into your self. Okay, so this is the third level of integration. We have functional integration, homeostatic integration, and we have personality integration. If you can achieve that, you're gonna have, okay, it sounds like self-help, but you're gonna have so much more psychic energy because you're gonna know how your psyche works, all right? I know it sounds like a little self-helpish, but I do think that we have a substance here to base that, okay? So, integration and polymathy. If you look up to the dictionary before us, I mean before myself and Ruth Bernstein and others, they would say, polymathy is encyclopedic knowledge. That's not wrong, but that view has been overtaken. It's a view of the Renaissance when they thought they could organize the knowledge into some, it's like you have this decision-making paths. You go there and there and there and there and there and there, and if your tree has enough branches, you have all the knowledge in the world. That's like a dream of the Renaissance people, but that's not, in my opinion, and the opinion of others, what polymathy really entails, okay? So if you have already read it, lots of people who have really studied polymathy say that integration is it's not important, it's a fundamental pillar of polymathy. And then I come to my own organization that polymathy entails breadth. Of course, you cannot be restricted. You cannot be narrow. If you're narrow, you're not a polymath, of course. But you cannot forsake the importance of depth, because otherwise you're going to be a dilettante, a person who has lots of various interests, but is very superficial and doesn't connect them. Just goes to the internet, okay, let me check that, forgets it, and then it doesn't add anything or pretty much to their psyche. And finally, I hope you are convinced of that. That is a new assertion, that integration is the third pillar of polymathy. Okay, so let's go from polymathy to creativity, which is the purpose of the talk here, is to integrate those stuff. And, all right, we have the domain that I explained. It's not something that you should believe. And we have a fight. That's a cultural revolution. What or who are gonna make into the domain? And you notice it's not a closed thing. Some ideas come in, others are rejected, all right? Not just, but it's a very good metaphor to use. Our DNA, all right? We have lots of junk DNA, by the way, DNA that people don't know what it does. It's like have many things like that in our culture. We just have them and carry on forward, but maybe they're not very useful, but they are there. They made it there. All right. But one thing that I like in this metaphor, that when you can insert it in the culture, it crystallizes the idea or the thing or the notion or the fact or whatever. And then we have this interesting approach based on the work of Dawkins, of course, the selfish gene. I would say selfish meme, or no, it's not. It's the meme from the selfish gene. And we have Sperber, Blackmore, and Hurst, 2008. They have used, not him, but they have advanced what is called the epidemiological approach. And this is my own mutation of that, okay? They don't say that's my own invention. But take the time to read it. We have 6 steps, okay? That's an illustration of how things evolve. You collect from the environment some viral molecules, but when they enter your head, you incubate them and you make your own virus. You transmit it to people. That's the very same word that biologists use. But people may be more or less resistant to it, okay? Depending on their immunological system, right? And psychologically speaking, depending on the personality, their biases, they will be more or less prone to take one idea or another. And the virus may, in fact, will also mutate in another person's organism. I don't replicate the ideas of the researchers that I like, that I find truthful. I don't. I pretty much integrate and mix it up and come up with something actually different. And then, after all, in real life, we have the gatekeepers, they accept or not, but those who are accepted make into the domain or into the DNA. Very neat metaphor, okay? And then I construct a model of creativity. It's not a new model, okay? I took ideas from many researchers since the beginning of psychology, new researchers, new theories. I try to make it as simple as possible. So we have 4 things, and we have 2 states and 2 levels. Everybody by this time should know that creativity is not a personal phenomenon, it's a social phenomenon, right? So, we start with the domain, and we collect ideas from the culture, right? We form our personal sample. If you go to psychology school, you're gonna have a different sample from somebody who goes to economics or who goes to mathematics, whatever. You get your sample. Mainly here I'm focusing on the crystallized material. All right, but you're not a rock. You do something. This is very stable because here is replication, right? So just like you learn a subject from the textbook and then you have a test. If you are okay, it means that your sample is fine, right? You replicate the extant knowledge. But then you have some fluid going on in your mind. You ideate, you make new and different stuff. And some of them you elaborate to a social level. I will explain it in more detail later, all right? And you make a new product. Here is not the product, that's the idea. The idea that may be time and simultaneity is the key to understand physical reality. But you have to elaborate on that. You have to present a paper with an equation. Einstein did not think, did not wake in the morning, oh, E equals E equals mc squared. No, he had a lot of time to ideate and to make this paper, which is the problem. That first did not enter into the domain. Nobody cared for the first paper of Einstein. Nobody gave a for him. After some review, people from the domain, gatekeepers, started to notice his work. Oh, there is something real going on here. And then he finally made it into the domain. And then I have a little less simple model of creativity. So let's add a little more complexity. We all know about the personal sample that is collected from the domain, but no, not only from the main domain. You can have a different sample. We have marginal knowledge that is there, but the gatekeepers are not paying attention. And we have knowledge from other domains that are out of the radar of these people. And then we have what I call self-elaboration. You have experiences, you have events. I've been to a talk here about the creativity or the creative process of writers. And there was a writer who had a problem. She couldn't finish her book, and she was washing dishes, and something came to her that she should change the whole angle of the story, all right? And she began to elaborate. But she had a story in her head, but that only her knew, that only her had access. It's like my talk before today, only I had access to it. So it was my unique mathemata, okay? It's a word based on the very famous word of Piaget, schema, all right? But a schema can be something that you acquire unconsciously. For example, Italians like to talk like this and loud. And then if you replicate that, that's a schema, right? You can replicate that, you can internalize that, but that's not a mathema in the way I define it, because this one requires a little bit of reflection. Doesn't mean that mathema is true knowledge. I'm not naive to use the word true in anything, but it is knowledge that you can act upon it. And then I draw from the pragmatists, Charles Sanders' Peirce, with this knowledge that you can act upon it. It's okay enough for you to continue to use it. Okay, that's your mathema. Maybe wrong, but it's useful to you. And it's very common that in this process, and I can tell my story, when I discovered Polymathy, I went to the internet, let's see what is there. And then I became aware of Ruth Bernstein's work, of Beghetto and James Kaufman, and many others. And then I was into economics, and I thought, okay, I may be the only guy on earth who has this knowledge in economics, and I'm gonna bring it back, and I'm gonna be revolutionary. And then I got to know the paper of Robinson and Rumko, the psychoeconomic approach. Oh my God, that's a rediscovery. And that's it. Maybe if I wasn't interested in polymathy, I would never go to the domain and get this knowledge back to me. And finally, you have the social elaboration, which means the product. That's one product that I'm showing to you. And then I have this more stable things and more fluid things when you are elaborating. That is maybe the 57th version of my presentation, all right? So you do a lot of elaboration here. It's fluid. And this is stuck, how can I say, that's written on the rock. Once it's published, you can make amends, but it's there. It's like accountability. It's done, all right? And people can go after your work, your early work, say, oh, you said that in the past. They, okay, changed my mind, but but it's there forever in the domain. All right. And then to add to my model, let me go back. You see this quadrants. And then I try to add, in fact, I did not try, I just realized that they look very similar to the 4P things of creativity, the person, process, product, and press. And let's check each one of them. First one is building your conscience. All right, so what's your sample of the world? The first thing is what set of ideas will make up your consciousness. All right, so if I tell you, think of a tree, just picture a tree in your head, okay? Probably you're gonna have pictured something like that. Why? Because your experience is something like that. But if I go to Africa, I may have a totally different answer, right? So the material you have to begin with to be creative, you can't be creative out of nothing. You must have material in first place to make the combinations. Don't come from nothing. All right? So one possibility, one thing that polymaths, and not only polymaths, some authors, especially in German, the concept of education in German called Bildung, especially from Alexander and Wilhelm Humboldt. He has a famous sentence, by the way. The most dangerous worldview is it's more or less the most dangerous worldview is that of those people who haven't seen the world. All right, so you must see the world, not to have a dangerous worldview, because if you come from only one background, it's very possible that when you come to power, you're gonna want to extrapolate that view to anybody else. Okay? When you enlarge your worldview, what is a tree? You step back. Okay, that may be a tree, 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 that may be a tree. But if you're not polymathic, you have only one tree, all right? Okay, that's one step. And another thing, another distinction that I like to make is between sampling and composing. Sampling is like the DJ. He gets music that has been already done and he just chunks it in a different piece. It's creative, but when you compose, you start from scratch. You go there, you go back to the basic of notes. And some modern composers have gone so far that they challenged our 12-note scale. Okay? Great. Ideation process. Then I have this other model of how can you come with novel ideas? First, you must have material to work with. What's the quality? What's the diversity? What's the depth of your material? Okay, this is a very good sample. A person who likes psychology and music and chemistry and tennis and mathematics and poems, that's a Chinese poem, and dance and Shakespeare, plays and cars. All right, that's not me, just an example. But you can have these different sets here, inputs here, but you also have different processes. We learned in the talk yesterday about different cognitive styles have been by for a long time, but we have biases for different processes, all right? And some people are so biased that they only want to use one process, okay? Although we may be natural in one process, we should acquire a taste for the different processes, okay? And this is it, and this is our outcome space. Mathematicians would say the probability space. All right, our default behavior tends to be modular, right? I have a problem. This is a physics problem. I'm gonna go to physics textbooks, all right? But I lose all those possibilities of combinations. It's good when you are a student doing a standardized test, solve for x. Okay, I have to use Bhaskara's formula, and then I have to calculate. This is easy, step by step. You go there, you don't have to walk around a little bit. Modularity. But you have the power of no modularity. Imagine that. If you have a problem, and that you could entertain the chance that any dot may be the answer? You don't know because it's blind. If we do know the answer beforehand, you don't need creativity. You go to the book and, okay, I apply Bhaskara's formula. Okay, well, how creative is that? And then I go to the radial metaphor that I took from Herbert, who is here yesterday. Just changed this slide. This is pretty new. So we have this knob, okay? And you want to tune into a station. Okay, let's say your station is 989. And then when you tune into 989 here in the knob, you get the best signal to noise ratio. So we've got a lot of signal. It's very clear. You can hear the guy talking or singing, whatever, and very little noise. But when you change the knob a little bit to the left, to the right, you start getting more noise entering in the signal, right? And metaphorically, many people, they are so used to a certain radio station that when they start to change a little bit the noise, the knob, and the noise starts coming in, what's your natural behavior? Oh no, let me go back to the station that I'm used to. So when you go from one station to another, you have to be brave enough to endure the period of noise that's gonna be in between. And imagine if you do that, or if you have done that for many times, for some years in your life. Okay, I love this radio station, but let me tune into another one. And then you, oh, noise. And you are a kid, you feel afraid, okay, I want to go back to my station. But if you actually make it to the other station, this process becomes less painful to you. You start understanding more, okay, that's noise, that's part of life, I have to deal with that. And then, I love mathematics. These are some mathematical models. And then, okay, we all have divergent and convergent thinking. Let me try to make an illustration of that in mathematics. And I didn't make it. I borrowed from finance. They have this process called mean reversion process, which means that you are at point 100, but you already know that the mean, the expected point is 50. So you go all straight from 100 to 50. All deviation from that is noise. You want to go as fast as you can from 100 to 50 because you know that the solution is at 50. So the more you reduce noise, the more it's going to be like that. That's what we are doing to the students. Reduce noise, okay? Don't make mistakes on Bhaskara's equation. Use it right. Don't make mistakes on your calculation. Noise is bad. But when you have ill-defined problems, when you have brand new problems, when you have problems on the intersection of disciplines, when you have new stuff coming on Earth, you need noise. Noise is the solution, not the problem. And the basic way to mathematically model noise is through the random walk. The point is, let's say the solution is here, 125, and your starting point is 100, but your feet or your legs are not large enough to go from 100 to 125. And you are blind. You don't know beforehand that 125 is the final answer. So you walk like a drunk person, okay? That's the famous random walk. But if you do not allow yourself to behave like the drunk person, you will never arrive at 125 or any other answer that is different from 100, all right? Your path is going to be a straight line. And then I invented this diffusion model of stochastic process that I have. This is mostly noise, okay? Mostly no, this is all noise. It goes randomly, up and down, 1 point, okay? That's the random walk. And then I invented the mean aversion process, which I think it may happen in the minds of creative people, which means I want anything but that. So every time I approach this point, there is a strong force to repel me from that point. And I think of Einstein. He was thinking there, okay, Maxwell equations, And then he came to Newtonian physics. No, I don't want Newtonian physics. I want anything but that. And then when he get that, he was repelled to a different point, and I made this equation based on Newton, by the way, of this process. That's a simulation on the computer, right? Each line here is a path, a random path, and they arrive at very wild, different endpoints, outcomes. And let's go to the elaboration processes. How much time do I have?
It's 11:21. You have 9 minutes.
All right. So first, the product. There is the big translation, which is we often think using images, feelings, abstract architectures that have no domain-specific identities, right? Einstein did not think E equals mc squared at first. That was a secondary translation step. So I call it the big translation, from the things that work in your head to things that you can publish for the outer public to appreciate, right? That's a great problem. And we have the gatekeeping process, which has advantages and disadvantages, like everything on Earth. And the big advantage, I love this sentence. People made a song on that. If you wish to make an apple pie from scratch, you must first invent the universe. This is Carl Sagan's. They made a rap song on that. That's so interesting. All right, so most of the time in our life, we don't need to if you want to make an apple pie, you just go to the internet and get the recipe, right? That's why we have culture, right? Not to invent everything from scratch. But of course, there is a very dangerous menace if you believe too much in the domain knowledge, and it takes a historian to take a distanced look on that. And I like this guy pretty much, Peter Burke, a historian, specialized here, I use the word, with expertise in the Renaissance period. And take your time to read. Remember the beginning. Why bother? Why polymath? Why is it bother? I don't want to be a polymath. Bother socially, bother socially too. So sometimes it takes a polymath to mind the gap and draw attention to the knowledges that might otherwise disappear into the spaces, into the gaps between the disciplines as they are currently defined and organized. So we have seen many talks here about the evolution of the ideas. So nothing's written on the rock ultimately. And I would like to finish with this very beautiful text here by Wilhelm von Tobel. Take note of the date, all right? Very interesting period in the early Germany and Prussian world. Rich people like him afforded to be able to travel to the world, to have this worldview that we all want to have, all know, but many of us want to have, to draw from different experiences. But when you look to the traditional definitions of polymathy in the dictionary and encyclopedic knowledge, that's not it. Encyclopedic knowledge may be fun, but the really next step, what's really impactful about polymathy, is when you use all the knowledge, all the breadth, all the depth, and all your capability of integration to generate something new that is going to leave, that's going to impact society by the means our vital activity. So that's how I would like to end my presentation today. Thank you very much. Well, questions? Yeah, you.
Firstly, thank you very much. It was a really interesting, interessant.
Very good.
Two things jumped out at me. One was going back to the novice effect. I seem to spend my life as a teacher and in my commercial work trying to get people to be more creative. And I loved the notion of sort of saying, take that topic and choose 2 different magazines to write about it. You know, getting people maybe to reframe an idea as if you're writing for two different magazines from different perspectives. I thought that seems to me to have a lot of interesting kind of repercussions. The other thing is going back to you know, where your kind of domain knowledge tails off, the curvilinear kind of part of that. And it's my own career path has been sort of a tad unusual in that I started life as a graphic artist and a journalist, and then went and did a master's degree in medical physics.
Oh, great.
And then 20 years later did my PhD in social psychology. But as my days as a physicist, I filed 10 different patents in the area of ultrasound and so forth. But they were all filed in the first 3 years of my being a physicist. And I know from the kind of writing in my own notebooks and that kind of thing, when I switched from graphic arts and journalism to physics, the way that I thought about things began to change. That my approach to problems, my approach to the world in general and life, as an artist and journalist, was very different to the way that. But it took a time for that to change, and so I think maybe there are obviously lots of explanations for that curvilinear kind of process, and most of them involve kind of being super saturated with the kind of knowledge you're surrounded by. But I think that there is a cognitive pattern that goes on when you become immersed in a particular field, not just the data that you're surrounded by, but the actual way that you piece those pieces of data together.
Perfect.
And I know that, you know, as I say, from that transition for me, that it was very obvious to me that the way I was thinking about things changed over the course of about 3 years. And then, so my last sort of couple of years as a practicing medical physicist, I really didn't do anything very creative at that point. Somehow or other, I was now beginning to think in cognitive patterns that were exactly the same as all the other physicists around me.
All right. Okay, thank you very much for your question. Well, I think you should talk to the guy to your right. He's the person who structured everything you said. He did research on that, interviews with many people to find out that exactly what you did. People who made these little changes, had this effect, and that's his term, not this effect. All right. Any other question? I don't know if I answered it because I think we are running out of time. I'm so sorry. We can talk more afterwards. Yeah.
Thank you, very interesting talk. I think we share many questions. And I was just wondering how interdisciplinary and multidisciplinary all those terms fit into
Yes.
Polymathy.
Yeah,
How
of
that
course.
relates.
Yeah, it relates. The problem is people made so many terms over time, and then I have now an interdisciplinary test. They just remove the names. Like, it's not biology, it's not mathematics, but the questions are the same, and they call it multidisciplinary. This is not it. Polymathy, in one sense, it can be an instrument for you to be more creative, but it can be, as I see it, a worldview, a way of seeing things, like Humboldt put. So it is, of course, interdisciplinary. But would you say, okay, I have an interdisciplinary trait? Maybe it's semantics. I can have a trait, polymathy, a constellation of characteristics, which, when it is present, it will moderate the descent of the curve. Okay? It will cause a moderating effect that will, right? It may be, that's my thesis, it may be this constellation of personal characteristics, which I call trait polymathy. And I need funds to continue this research. Hubbard.
Okay, that was very, very cool.
Thank you.
I'm totally new to this field, and now I get it, which I very much appreciate. And this image that you had towards the end of these two giant blocks and the gapping, that reminded me, there was, passed away unfortunately, a very famous person on giving TED Talks, Hans Rosling.
I love him.
And his company is called Gapmind.
Yeah, I know.
And what he does basically is bridging those gaps.
Yeah.
So in a way, he may not have been aware that he was a proponent of polymathy, but absolutely he was, because, for example, in my experience, I have no experience or interest in finance or in statistics as a creative director, but he made me love it. How cool is that?
Very. No, he is so cool that I instead of me teaching these things to my students, please watch this guy because we give the students those economics books and they see those plots with the big dots for big countries and sometimes they see, sometimes no. In Brazil, you know, education is very low, so they feel overwhelmed. They feel bewildered, and we have a language problem too there. But anyways, I show them Hans Rosling. Some of them love it. Some of them just don't care. But for those who love it, it's like the lightning strike. And the term polymathy is not that's the problem. Interdisciplinarity doesn't change lives. Polymathy maybe does. Okay, this is the lightning strike that if it had been there when I was 13, my life would have been so much easier. But it's not. All right. If I want to apply to a psychology PhD, they say, "Oh, you're from management." But I'm sorry, but look at my work. Look at my references. You know, that's just a box. And you know, when this word didn't solve the problem, maybe polymathy will. Okay? I don't know. Do we have time for more questions?
Well, we are officially on break, and of course you're welcome to use the break as you please if you'd like to stay here and speak.
Well, for
So,
me,
yeah.
please.
Interesting factoid for the people that are interested in Vladimir Nabokov. He wrote Lolita in Ashland.
Oh my God!
Whoa!
Vladimir Nabokov wrote Lolita right here in Ashland. Some of his butterfly collecting
Was here, indeed.
was here with his wife. But there's actually a plaque if you're interested in going to Mead Street.
You send to this email, please. I want to know.
There's actually a plaque on outside of two townhouses there that talk about him. He has a connection to Southern Oregon University in the Department of Social Sciences here as well. You can find this on Wikipedia.
Thank you.
I just wanted to mention that if you weren't aware of it.
Thank you.
I would love to. If I can.